Hey guys, so for today guys practice, we're going to do a problem that looks like what you're going to see on your assignment today. So these problems are a little bit bigger than we would normally see. That's why you have less of them today. So they're going to be multi-step. And you're going to need to be able to represent, just like we did in the video, we're going to be able to represent our function in a number of different ways. So this one says, the school cafeteria sells lunch passes that allow a student to purchase a number of lunches in advance for $3 per lunch. So I know that $3 per lunch, I bet that's going to be my rule, because for however many lunches, there's going to be an additional $3, right? So I can go ahead, I would probably go ahead and fill in the function table first, just because that way I know what I'm dealing with when I'm looking for my equation. So like for one lunch, let's just do one lunch, two lunches, and three lunches. So for one lunch, I know that it's $3 for a lunch. Okay. Now, I know my second lunch is going to be another $3, right? So for two lunches, it would be 3 plus 3, or $6. And for my third lunch, I know it would be 3 plus 3, which would be 6, plus another $3, which would be $9 for the lunch. And again, like we've done in the past, we can look at this to help us figure out our rule. So these are all getting greater by a factor, being added 1 each time. And this down here, we're actually adding 3 each time as we go up. So this is a 1-to-3 ratio, so I know that I am going to be multiplying by 3. So I know that n is my variable. So since I'm multiplying by 3, I would have 3 times n should equal t, or my cost. And we can check that on our board over here. If I plug in a 1, 3 times 1 is 3, and that is my answer. If I plug in a 2, 3 times 2 is 6, and that's what I have here. 3 times 3 is 9, and that's what I have in my chart. So this is an accurate representation of our function. So this would be a representation of our function rule. We can also use that along with our table to represent our function. And then we can also graph these as ordered pairs. And remember, this would be your x value, your input is your x, and your y value, or your function of x, would be the output. And we're just going to graph these as ordered pairs. So my first ordered pair would be 1, 3. I'd go over 1 and up 3, right there. My second ordered pair would be 2, 6. So I would go over 2, and I would go up 6. And last but not least, I would have 3, 9, go over 3 and up 9. And then I can take and I can add, or I can connect these dots together and make a lovely straightish line. If I had a ruler, I would do that. You can make a straight line between those. And here again is your fourth way we can represent. So we've represented this as, we could say, the equation would be 3n equals t. We could show our representation as our function table. We could show our representation as the graph. So that's 3 of your 4 ways that you could show this, this function, represent it differently. You could also say that to find the total cost of all the lunches will be 3 times however many lunches that you buy. That would be the 4th way we could show our function as a sentence. So there you go. There's the 4 different ways you can show a function. As you are working through the independent practice problems today, please make sure you're going through and doing each of those things. Remember, if you've got your points already, you can go ahead and plug them into a chart. You know what your x and your y are, so you know what your inputs and your outputs will be. You can use that then to come up with the function rule. So if you have the points, that's how you would start and go backwards. If you have the function table, you can usually figure out your rule. If you have the rule, then you can make a table then and get your ordered pairs and go backwards and find your graph that way. There's always a way to get to all 4 of the types of representation that we've talked about with one of these given pieces of information. All right. That's what we've got for today, so go ahead and try that independent practice. If while you're working on these you have trouble, please make sure to hit me up during office hours. I am here for you. All right, good luck.